Hi guys, today we are going to study about the equilibrium of concurrent and non-concurrent forces. Well, what is equilibrium? Well, a system of forces acting on a body are said to be in equilibrium when the resultant of all the forces is zero and also the algebraic sum of all the moments of the forces is zero. Hence, from this we can see that when an object is in equilibrium, then it means that all the forces and moments are balanced and hence the net resultant will be zero, which implies that the system of forces or moments applied on the body will not bring about any change in the state of motion of the body. Hence, from the definition, we can say that the conditions for the equilibrium are that the resultant, that is the square root of summation h square plus summation v square, should be 0, and summation m, that is the summation of all the moments, should also be equal to 0. This basically means that summation h, that is the algebraic sum of horizontal components of the forces, should be 0. Summation v, algebraic sum of the vertical component of forces, should be 0, and summation m, that is the algebraic sum of moments of all the forces about any point, also should be 0. Now, let us see the principles of equilibrium for the different force systems. Well, this is basically the principle which states the different conditions for equilibrium for different number of forces acting on a body. First, the two-force system. In this system, two forces will be simultaneously acting upon the body. Hence, the principle states that if a body is acted upon by two forces, then for equilibrium, they must be equal in magnitude and opposite in direction and collinear. This means that the two forces will be equal and acts in the opposite direction in the same line. Hence, the net resultant of the force will be 0 and hence the equilibrium of the system will be attained. Next, three-force system. Well, it is a system in which three forces will be simultaneously acting on a point of the body. Well, this principle states that if a body is acted upon three forces, then for equilibrium, the resultant of any two forces must be equal, opposite and collinear with the third force. This means that when three forces will act on a body, then the resultant of the two forces should be equal and opposite to that of the third force and also must be collinear to it. Hence, this will bring up the condition of the two-force system, which ultimately leads to the equilibrium. Next, four-force system. Here, four forces will simultaneously act upon a body. Hence, it states that if a body is acted upon by four forces, then for equilibrium, the resultant of any two forces must be equal, opposite and collinear with the resultant of the remaining two forces. Hence, from the statement, we get to know that when there are four forces acting on the body, we will get two resultants from these forces, which will then behave like a two-force system, and hence the equilibrium of the system can be attained. Next, what is an equilibriant? Well, equilibriant is a force equal in magnitude and opposite in direction and also collinear with the resultant, which is added to the system of forces to bring in the equilibrium. Well, it means that if a system is not in equilibrium and if we want to bring it to the equilibrium state, then we will add a force to it which will be equal in magnitude and also act opposite to the direction and will also be collinear to that of the resultant of the already existing forces. Hence, the force added which brings about the equilibrium in the system is known as the equilibriant. Thank you.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.engg.